Hello children, I welcome you all once again to online tutoring class for class 9 science. So this is my fourth class with you all. In the last class we started on a topic that is gravitation chapter 10. So this class will be the continuation of the previous class. But before we start, let us go back and recap whatever we have learned in our previous class. So we have already learned that the force of gravitation is due to Earth, and we call it as gravitational force. That means it is because of the gravitational force of the Earth that pulls the object towards itself. And we have also learned that every object in the universe attracts every other object with a force which is proportional to the product of their masses and inversely proportional to the square of the distance between them, and that we call it as universal law of gravitation. And also we have learned that when two objects are lying very close to each other, the force with which they attract will be more, and that means the greater the force, the more will be the movement of an object. And another topic that we have learned is that free fall. Free fall means when an object falls towards the earth with no other force acting on the body. When an object falls towards the earth with no other force on the body except the gravitational force of the earth, we call it as an free fall. And when the object falls towards the earth, acceleration is involved. That means there will be change in velocity. That means velocity will increase, and this velocity increase in this acceleration, change in velocity, this acceleration is due to Earth's gravitational force, and we call it as acceleration due to gravity. So this is all what we have learned in the earlier class. So today, for today's class, let us start with mass and weight. So again, this mass, when I say mass and weight, this is again a very common word that we use every day, that we hear every day. Say, when I say, for example, you go to the grocery shop to buy, say, 10 kg of rice, okay? So you went to the grocery shop to buy 10 kg of rice. So for a common people like us, we will think that this 10 kg is nothing but this is the mass of an object. That is, object is here, rice. So this 10 kg is nothing but the mass of an object, and also this 10 kg is also the weight. This 10 kg is also the weight of an object, that is rice. We often think that these two words, that is mass and weight, are same thing. We people, we often think that these two words are same thing. There is no difference between these two words, that is mass and weight, but that is a misconception. This word mass and weight are totally two different things. That means two different words with two different meaning. And in this chapter, we are going to learn what is mass and weight according to science. So let's start with mass. So in the previous lesson, we have learned that mass is nothing but the measure of inertia. So we can define mass as the quantity of matter possessed by a body. Let me write quantity of a matter possessed by a body. So here, when I say quantity means what? Let's take the same example, this 10 kg of rice. If I ask you what is the quantity of the rice that you are holding, then you will say it's 10 kg, right? So that means mass is nothing but 10 kg only. It is the quantity of this object. So mass always remains the same, whether it is on Earth or whether it is on other planet or whether it is on Moon. Mass will always remain same. It will not change from place to place. That means 10 kg of rice means it will just remain as it is as 10 kg, whether it is on Earth or on other planet. That means mass is always constant. Now let us see what is weight. Weight is nothing but the force with which, let me write, weight, it is the force with which the Earth attracts an object. Okay, let me repeat once more. Weight is nothing but it is the force with which the Earth attracts an object. Again, let us take the same example, the 10 kg of rice. As I have told you, 10 kg of rice means this 10 kg is nothing but a mass, right? But when I ask you, if I ask you what is the weight of this 10 kg of rice, what is the weight of this 10 kg of rice, then what will be your answer? It's very confusing, right? But as we go on, you will get to know it. So if I say the weight of 10 kg, what is the weight of this 10 kg of rice, then that means the weight of 10 kg of rice is nothing but a force with which that 10 kg of rice is being attracted by the Earth. So as I have said, mass, it is always constant, it does not change from place to place, whereas in case of weight, it changes from place to place. So now let us find out, okay, let us find out what is the weight of this 10 kg of rice. So from Newton's second law of motion, we know that in the previous class, we have already discussed about this Newton's first law, second law, and third law. So from Newton's second law of motion, we know that force is equal to mass into, since we are talking about this acceleration due to gravitational force of the Earth, the acceleration will be acceleration due to gravity. So now here see, we are talking about this 10 kg of rice, and we are going to find out what is the weight of this 10 kg of rice. So here 10 kg means mass is how much? Let me write here. Mass is how much? Then this is 10 kg, right? So mass will be 10 kg. So let's put the value of this mass over here. M is nothing but mass, and then G is acceleration due to gravity. And then in the last class, I have told you that the value of acceleration due to gravity is 9.8 meter per second square. The value of acceleration due to gravity is 9.8 meters second square. So since after decimal, it is more than 8, right? So we can write 10 meter per second square. So let's put the value of this mass and then acceleration due to gravity, that is G, in Newton's second law of motion. So here mass is 10 and acceleration due to gravity, that is G, is 10. So the total will be 10 into 10 is 100. And the unit will be, we know that the unit of force is what? Unit of force is Newton. So the unit will be Newton, 100 Newton. So this 100 Newton is nothing but the weight, okay? This 100 Newton is nothing but the weight of this 10 kg of rice. I hope you are clear with this weight difference between the mass and weight. Now let us see what is the weight of an object on moon. Now let us see what is the weight of an object on moon. We have, as I have already explained it to you, that weight of an object on Earth is the force with which the Earth attracts the object. Whereas, however, weight of an object on moon will be similarly, the only difference will be in place of Earth, the definition will be same, but in place of Earth, you put moon, okay? So the definition will be the weight of an object on moon is the force with which the moon, okay? The definition is same, except in place of Earth, we have to replace it with moon. So in which the object, which the moon attracts the object, and the mass of moon is lesser than that of the mass of Earth, and that is why the moon exerts a lesser force on moon, and mass of an object on moon is 1/6, okay, is 1/6 the mass weight on the earth. I repeat again, weight of an object on moon is 1/6 the weight on earth. That means on earth, on moon, it is 6 times lesser, okay, it is 6 times lesser. Let me write, weight of an object on moon is equal to 1/6. 1/6 means 1/6, right? So weight on earth. So weight of an object on moon is 1/6 the weight on earth. Let me give you an example. For example, your weight, okay, your body weight is 60 kg on earth. Say your body weight is 60 kg on earth. So when you go to moon, what will be your weight? Let us calculate, okay? If your weight is 60 kg on moon, then what will be your weight on moon? So the weight of an object, so using this formula, we will be able to calculate. So weight of an object on moon is equal to 1/6 into weight on earth is how much? 60, right? Your weight is 60, so you put here 60 instead of this, and then cancel it, 10. That means 10 kg. Your kg will be 10 kg on moon. If your weight of your body is 60 kg on earth, then when you go to moon, your weight will be 6 times lesser than that on earth. That means it will be 10 kg. So I hope you are clear with this. Let us go to the next topic is, I want you all to turn your textbook to page number 148, thrust and pressure. THRUST, thrust and pressure. So in order to understand the concept of this thrust and pressure, let us look at some of the examples in our daily life. Say, for example, you want to place or you want to fix a poster, okay? So you want to fix a poster on the bulletin board of your school. So say this is a bulletin board, and then you want to fix a poster on the bulletin board of your school. So in order to do that, what you will need? You will need a drawing pen, a drawing pin, right? So with the drawing pin, you have pasted the poster on the bulletin board, and then you will keep this drawing pin over the poster, and then you will press it with your thumb. Yes or no? You will press it with your thumb. That means when you are pressing, you are doing some work, right? You are applying some force. If you don't apply your force on your thumb, then will you be able to press it? No, right? That means in order to put this poster, you have to press this drawing pin with your thumb. That means when you are pressing it on the surface area of the head of the pin, that means that it looks like this. That means the total force that you are applying with your thumb, okay? The total force that you are applying with your thumb is acting perpendicular, see? Is acting perpendicular, is directed perpendicular to the surface area of the board, yes or no? When I say perpendicular, it means 90 degree, we all know that, right? Right angle. That means the total force on your thumb is directed perpendicular to the surface area of this bulletin board or the poster that you have pasted. Again, let me give you another example. Like say a table is broken, okay? And one table is broken and you want to fix it. So in order to fix it, what you will do? You will need a nail, and then iron nail, and then you will need a hammer, okay? So what you will do, you will put the nail on the board, on the table, and then you will apply a force with your hand and on the hammer, and then you will hit the hammer, right? Hit the nail. So even in this case, this is nail, so this is table. That means the total force applied on the surface area of the pin with your area of the head of the nail, iron rail, is directed perpendicular, even in this case, right? It is directed perpendicular to the surface area of the table. That means in both the cases, the total force is acting perpendicular to the surface area. So the total force which is acting perpendicular to the surface area is given a specific name, okay, is given a specific name, and we call it as thrust. So the total force acting perpendicular to the surface area we call it as thrust. And since this thrust is nothing but force, right? This thrust is force, so the unit of thrust will also be same with that unit of force. And what is the unit of force? As we have discussed in our earlier classes, the unit of force is nothing but Newton, right? So the unit of thrust will also be Newton. And the next is pressure. What is pressure? Again, this is another very common word that we hear it every day, right? So in order to understand this, let me give you again some examples. Say, if you stand on a loose sand, okay, if you stand on a loose sand, you will see that your feet will go deep inside the sand, right? If you stand on a loose sand, your feet will go deep inside the sand, but if you lie down, now the next is, if you lie down on the sand, then will your body go just as deep as into the sand, like when you stand? I want you all to experience it by yourself. You do it yourself. If there is sand around you, so if you stand, the sand will go deep inside. Whereas if you lie down on the sand, it will not go as deep. It will not go just as deep as into the sand like when you stood, right? In both the cases, in both the cases, standing and then lying down, it's you who is standing and then it's you who is lying down, right? That means the body weight is same. But then that means here the force exerted on the body is the weight of your body. But whereas in the first case, the depth is more, and in the second case, the depth is less. Why? Again, let me give you another example, okay? If you have a pencil with you, I want you all to take out your pencil, a short pencil, make it one end, sharp one end, and the other end just keep as it is. That means just keep it as blunt, okay? I want you all to hold your pencil in between your thumb and then index finger, that is in between these two, like this, and then pointing the sharp end on the index finger and then the blunt end towards the thumb. And then after that, apply same force on both the end, both index finger and then thumb. I want you all to apply same force and wait for a few seconds, say 4 or 5 seconds, and then release it, okay? Release it and observe your finger. You will see that the depression will be more on the index finger, that is the sharp end, where the pencil is sharp. The depression will be more on the index finger and the depression will be less on the thumb. Do you know the reason why? And that's where the concept of pressure comes in, okay? Pressure, we can define pressure as the force per unit area of a surface. Force pressure is nothing but the force per unit area of the surface. That means if the area is more, pressure will be less, and if the area is less, pressure will be more. If the area okay, so if the area is less, there will be more pressure, and if the area is more, there will be less pressure. From the first example, okay? First example, say you are standing, okay? You are standing here. This is your 2 feet on the sand. So the area, the surface area is how much? This much only, right? Only less surface area, and that is why your feet goes deep inside. That means more pressure. If the area is less, more pressure. And then when you lie down on the sand, say when you lie down on the sand, the surface area is from here till this much, right, the surface area is more. And since the surface area is more, the pressure will be less. Same with that second example, the pencil, the sharp end, say this is pencil, this is a sharp end, so since the surface area is this much only, it is less, and that is why the pressure is more. And the blunt end, the surface area is this much comparing to the sharp end, and that is why the pressure is less. And mathematically we can write pressure as pressure is equal to force divided by area. Okay, from the definition we can write force, okay, and area. This is the mathematical formula. Or since here we are talking about force is nothing but a thrust, right? So pressure we can also write thrust divided by area. And the unit of this pressure is Newton meters per meter square. We can write like this, or we can write Newton per meter square. It's just the same thing. So I hope you are clear with these two concepts, that is thrust and pressure. And the next topic is buoyancy. The next topic is buoyancy. Now, what is buoyancy? So again, let me give you another examples. I'm going to give you so many examples. So have you ever thought, or have you ever wondered why a big ship, right? Big ship made of big iron and steel, they just float on the water. Whereas if you keep that same amount of iron and steel in the form of sheet on the surface area of the water, then what will happen? The iron will sink, right? So have you ever thought, or have you ever wondered why these things happen? Or say you want to fetch water from a well. So when you put the bucket inside the well, so you will feel that when the bucket is inside the well, okay, inside the water, I mean, when the bucket is inside the water, you will feel that the weight of the bucket is light. Whereas as soon as you start pulling out the bucket, you will feel that the bucket of water is heavier when it is out of the water, right? So do you know the reason why all these things happens, as I have given you two examples? And all these questions can be answered by taking buoyancy into consideration. Again, let us all again do one activity. So all you need is a glass tumbler or a cup, and fill the glass tumbler or cup with water, and now you push the eraser, okay? You push the eraser at the bottom of the glass, at the bottom of the water, and after you push it, after some time you release the eraser. When you release the eraser, what do you all see? You will see that the eraser will come upward, right? Eraser will come upward, and then it will start floating on the surface area of water. That means this is because the force due to gravitational force of the earth exerts on the eraser in the downward direction, and the water exerts an upward force on the eraser. That means the upward force is due to the force exerted by the water, and the downward force is due to the gravitational force of the earth. And this upward force, okay, exerted by the water, we call it as a buoyant force or upthrust. So buoyancy is nothing but an upward force, and due to this buoyant force, or due to this upward force, the object appears lighter in water. So again, we have seen that when we place something on the water, some object float on the water, whereas in some other cases, when we place some object on the water, it sink into the water. Okay, so let me give you two examples here. One is, let's take as iron nail and then the same eraser. So if you place an iron nail on the water, what will happen? Will it sink or will it float on the water? Definitely it will sink into the water, right? Why? And on the other hand, if we place this eraser on the surface area of the water, it will just float on the water, it will not sink. Why? Because due to the differences in the density, because since the density of iron is more than that of the density of water, and so it sink in water, whereas the density of eraser is less than that of the density of water, and that is why it floats on the water. And also we can say that because the downward force, okay, the downward force is greater than that of the upward force, and that is why the object sink or the nail sink. Whereas in case of this eraser, since the upward force is greater than that of the downward force, and so the eraser floats in the water. So this is all about buoyancy. Now let us. Okay, the next topic will be Archimedes Principle. So this Archimedes Principle talks about the magnitude of a buoyancy. When I say the magnitude of a buoyancy, it means how much buoyancy will be exerted, how much buoyant force will actually get exerted. And this Archimedes Principle was determined by a scientist named Archimedes, and that is why it has been named as Archimedes Principle. And in my last class, as I told you that behind every experiment or behind every discovery, there is always a story, right? So behind this Archimedes Principle also, there is another very interesting story. So let us find out, let us learn how Archimedes find out this principle. Okay, so one day it so happened that Archimedes was about to take bath. Okay, so he went inside the bathroom, and then the bathtub was full of water. So as soon as he stepped inside the bathtub, he realized that the water level rises up and start flowing out of the bathtub. And from there he started thinking, and he thought to himself that there must be something which is compensating the weight of his body. And that's where he went for research. He started his research. He did so many experiments, and finally he formulated a principle, and we call it as Archimedes Principle. So Archimedes Principle, he said that when an object is immersed partially or fully in a fluid, it experiences an upward force that is equal to the weight of the fluid displaced by it. So whenever an object is immersed in a fluid, that means some amount of water will get displaced, and that water or that fluid which is displaced is equal to the weight of this upward force. Upward force means, we have already discussed that it is nothing but a buoyant force, right? So the water displaced will be equal to the upward force experienced by the object. So this Archimedes Principle, okay, let us again do one activity. Okay, so take 5 kg, take one stone. Say this stone, the mass of this stone is 5 kg. So tie this stone in one thread or a spring balance, tie like this, and then take one glass tumbler or a beaker. Say this is one beaker, and take one beaker and which have a small opening. Okay, which have a small opening on top. That means here has a small opening here, and then take another beaker, another small container or beaker here, and place it in below the opening. And after that, you fill this beaker with water, and so fill the beaker with water and fill it right up to this point. That means right up to the point where there is an opening. So, and then after that you lower down this stone, okay. Lower down this stone slowly, and if you lower down this stone slowly, you will see that the water level will start rising up, and then it will start falling here. The water level will rise up, and then it will start flowing out of the beaker. That means the water is rising up because of what? Because of the upward force exerted by the water, right? That means upward force is nothing but the buoyant force. So according to Archimedes principle, when an object is immersed partially or fully in a fluid, some fluid will get displaced. Some fluid is getting displaced over here, right? And the water that is displaced over here will be equal to the magnitude of the buoyant force, magnitude of this stone. That means the water that is displaced over there will be equal to the buoyant force, that is upward force. So this is all about Archimedes principle. So Archimedes principle says that when an object is immersed fully or partially into a fluid, it experiences an upward force that is equal to the weight of the water that is displaced. So the last topic, let's try to finish this chapter today. Last topic for today is, it's a very short topic, so relative density. So now what is relative density? Let me give you an example. Say let us take 3 cubes, okay, 3 cubes of same size. That means these 3 cubes have same size. Say all the sizes are 1 centimeter. 1, same sizes but of different substances. Say this is made of metal, this is made of glass, and this is made up of wood. And try to judge their weight. You will see that the weight of metal will be more, right? Even though they are of same size, the weight of the metal will be more. That means weight of metal will be more than that of glass, and then wood will be less. That means the density of metal is more than the density of glass and the density of wood. So we can define density as the mass per unit volume of a substance. Mass density can be defined as the mass per unit volume of a substance, and this density is denoted by the letter P. Written, we write like this, but this is nothing but RHO, rho. We call it as rho, okay? And the SI unit is SI unit of this density is kg per meter cubed, and the relative density is nothing but the ratio of the density of substance So the ratio of density of substance to the density of water at 4 degrees Celsius, we call it as relative density. So this is the formula of this relative density. With this, we have finished this chapter. We have come to the end of this chapter. So I hope all of you have learned and all of you have understood whatever I have explained from these 2 classes. That is the gravitation chapter. And whatever I have explained in these 2 classes, I want you all to go through your textbook, and I request you all to prepare your own notes, okay? Go through the textbook. Everything will be there in the textbook itself. So I want you to go through it and then prepare your own notes. And if you find any problems or difficulties, you can, I think all of you have your own concerned teacher's number, so you can call them and then you can clarify your doubts or you can clarify your problems from them. So with this, I end from here, and thank you so much.